Good morning, good afternoon, wherever you may be in your day. Thank you as always for choosing that chemistry part of your day. All right, part 3 of our little molarity mini-series. Much like Sharknado is a trilogy, here we have our molarity trilogy. All right, so we did solutions from solids, now we're going to do solutions from liquids. A lot of times this is called dilutions. All right, so for example, explain how to make a 250 milliliter solution of 0.1 molar HCl from concentrated HCl. Concentrated HCl being 12.4 molar. So let's take this problem in 2 pieces. One is this could be asked straight as a calculation. One could be asking you how to actually do it, or really having to do it in the laboratory. So let's take those as 3 separate approaches. Number 1, let's look at the calculation. We are going to take 12.4 molar HCl and add water until we get to 0.1 molar. So there's no chemical reaction going on. All we're going to do is dump in more and more solvent until we get to the number we want. This is called a dilution. And before I get into the math here, because the math is easy, everyone loves this calculation. They love using this, but they love it too much. It's like chocolate. You can't have chocolate for breakfast, lunch, and dinner. That's not good for you. We can't use this calculation for everything under the sun. It is a very limited calculation for dilutions only. So if we are doing a dilution, by all means, use this, please. It's wonderful. I love it. It's a great shortcut. If we are not doing dilutions, don't even let this come into your brain. All right, now that we've said that. All right, so this is clearly a dilution. There's only one chemical. We're just going from a high number of concentration to a low number of concentration, or what we call dilution. Okay, so that's good. So we can use it. Let me talk about the different versions. I use M1V1 equals M2V2 because that's what I was taught and it just beat into my head. Depending on your source material, you may see C1V1 equals C2V2, or even CIVI equals CFVF, or MIVI equals MFVF. So let me explain what we're looking at. Big M is molarity. Big C is concentration. What's nice about this particular formula is you can use any unit of concentration you want as long as it's the same on both sides. You can also use any unit of volume you want as long as it's the same on both sides. That's why people like to use this. We can do shortcuts. We can do microliters and millimolar, or parts per million, or whatever you want to use. So it works really nice that way. So it's really flexible, but it's only for dilutions. Okay, so sometimes you'll see it more generically concentration as opposed to molarity, because you can really use any unit of concentration you would like here. And then I still use 1s and 2s, but I actually like the I and the F better, because this is condition set 1 or time 1, and this is condition set 2 or time 2. And if you think about it as at the beginning initially versus your final solution, that goes well. And the key is just to make sure these things are linked. Whether they're both 1s, or they're both I's, or they're both 2s, or they're both F's, the solution, that concentration and that volume have to exist at the same point in time. They have to be talking about the exact same fluid in the exact same container. We can't mix and match. That's the only problem people have. So let's take this fairly straightforward calculation that I've built up for 3 minutes now. M1V1 equals M2V2. So initial and final. So, explain how to make a 250 milliliter solution of 0.1 molar HCl. So this is going to be a volume. This is a molarity. And that's talking about, you can tell, and this is basic, reading comprehension from your Core 101 class. These are together. This is talking about the same solution. So these are either going to be both 1s, or both 2s, or both I's, or both F's. And let me just stick with this initial final idea. This is what we want at the end. We're going to make this. So this is going to be our second volume and our second molarity. And it says from concentrated HCl, so this is a molarity, and that's going to be what we start with. You can notice we're missing V1, so that's what we're solving for. So this would just be 12.4 molar times our initial volume equals 0.1 molar times 250 milliliters. Now, all we have to do is divide both sides by 12.4 molar, and we are done with this calculation. Boom, boom. Our volume is 2.0 milliliters, since that's what's left here. Boom, and we are all done. And that's it. So you need to use 2 milliliters of stock solution. Now, the question didn't ask us how much we needed to use, it said how to make it entirely. So, what would that look like? Need a bigger table at home. Alright, so we're going to pipette that 2 milliliters, or she really should have 2.0, we want this to be precise. Pipette 2 milliliters of concentrated HCl into a 250 milliliter volumetric flask. So here's a little beaker, poured over a little bit of stock HCl down here. Here's my bulb, and you would put this down in the bottom. You would squeeze the bulb gently but firmly, place the bulb on top, and slowly release some of the pressure in your hand, and you would watch this suck up the tube. Bring it past the one line on the neck, break the connection with the bulb, and put your thumb over it. So it takes some skill. I'll demonstrate in lab. You'll get good at this. And then slowly, don't actually pull your thumb off the top, but just slowly release the pressure until this starts to go down. Get your meniscus so it's right on that line. You have exactly 2 milliliters. Bring it over so that it's over your 250 milliliter volumetric flask. Release your thumb and meditate. Don't shake it. Don't use the bulb to push it out. Just let gravity pull it out. Once it's all done, tap the tip to the end once, pull it up, put it back into a safe disposable place, particularly if you're using something like concentrated HCl, fume hood, waste container, those kinds of ideas. Then then the rest of it's exactly the same as before, as when we had the solid in the volumetric flask. So it asked us to make 250 milliliters, so choose 250 milliliters for your flask size. Whatever it asks, put there. Fill it 2/3 of the way with solvent, usually water, and mix it up. So same idea. Wait till it looks all clear and homogeneous. A lot of times you're mixing concentrated solutions with the solvent. They'll look kind of wavy. They'll look funky, kind of like looking over the blacktop on a really hot day. It'll look a little wavy. Wait for all that to settle out. A lot of times they'll get hot too with these dilution questions. So let that come to room temperature. And then fill it up to the mark, cap, with a cap, not your thumb, and invert 20 times, and you are done. There you go. Even easier than making solutions from solids is making solutions from liquids. Have a wonderful day.